to introduce briefly to what we are currently doing, all exciting stuffs and exciting researchers. And actually, there are really so many stuffs. If we hold like a workshop with very intense schedule, I think this workshop needs to be at least 7 days, Okay, so before I officially proceed, I would like to mention a few more things. The first, what does DAMO really stands for? DAMO actually stands for this the abbreviation of these 4 letters, that is discovery, adventure, momentum, and outlook. So that's the 4 capital letters of DAMO. And actually, I also would like to point out that DAMO in Chinese, DAMO Academy in Chinese actually means it's a group of people with really kung fu, very good kung fu or martial arts. Actually, I'm not one of them, okay? So that's one thing I would like to mention before I proceed. So the second thing I would like to mention is this graph neural network. So graph neural network, in one sentence to summarize, is that it's a combination of deep learning and the graph analysis. So it's also considered as the next generation of AI technologies because it can handle or tackle the 2 main drawbacks of deep learning, which is explainability, black box, right? The other is that it can do inductive reasoning. So GAN now is very hot in machine learning, data mining, and computer science. Okay, so that's the stuff I would like to point out before I proceed. Okay. So basically, my talk will consider 2 parts. The first part I will introduce very briefly. Actually, I will give you out the layouts of the DAMO Academy. I think it's probably the first time that DAMO Academy gives such a detailed layout. And in the second part, I will focus on this graph neural network in practice, especially with its application of search recommendation and the computational advertisements, which are actually core business, the most core business of the big data company. Okay. So this is the DAMO Academy. I think the previous speaker already mentioned that something related to it. For example, when it was founded, it was actually founded in this October 11th, 2017. And this name, DAMO, was actually named by Jack Ma, our founder. And our mission here is that we want to do research for solving problems with profit and fun. And regarding this DAMO Academy, it's actually considered as the foundation, the technology foundation of Alibaba Group. And above that, we have different enabling platforms, for example, like algorithm enabling platform, data enabling platform, and computing enabling platform. And above that, we support various of the business. For example, I'll show later in more detail here. Here, it's in more detail. As you can see, DAMO Academy is the foundation of this whole group. It's the boosting of the technologies. It's the core technologies for the next, steps of what Alibaba will do. And above that is the different computational, we call this enabling platform technologies. It's actually one of the Alibaba's most important policies that enabling Alibaba. And above that, as you can see, it supports various of the business like Youku. Youku is similar to YouTube. And the Tianmao Taobao is similar to Amazon. However, it has more, transaction, forms between the users and between the sellers and the buyers. And Cainiao is the logistics. And, this is most of you are familiar with. Ant Finance is about payments, right? And AliExpress targets for the European markets. Okay. So this slide actually represents a little bit how DAMO Academy, interacts with the well-being of the society. Because the reason Jack Ma, he founded the DAMO Academy, that's also his most important mission, to really do something for the society well-being. Okay, so on the left part is the 4+ laboratory research teams. One of them is the artificial intelligence, right? Consists of the most important parts like vision, speech, language, decision-making, city brain. City brain is very famous in China, and I will give you some details about the achievement of city brain. And the data computing, like the computational platform, computational system, robotics, smart logistics, and the financial technology. We have heard a lot about the blockchain here, right? And the X laboratory. X laboratory is the quantum computing. And on the right part, we just list some of the universities and institutions that we collaborate. For example, like the top university, Tsinghua University, Peking University, Zhejiang universities, right? And some other, worldwide top universities like Berkeley, Stanford, some others. For example, like myself, my team has very, very intense collaboration with brilliant researchers, professors from Tsinghua University, Peking University, Zhejiang University, Duke University, where I graduated, UIUC, Texas A&M, to work on these GAN problems was really very challenging. Okay. So in general, we have 300 plus researchers all over the world in 7 cities. Okay, so that's the layout that I just mentioned. I think this is the first time DAMO Academy released such detailed layout. So regarding this machine intelligence layout, as I just mentioned, we have various, these research areas like speech, NLP, natural language processing, and the vision, decision intelligence, city brain. So I will not go into detail about the technical directions. All kinds of exciting stuff are going on here. But I also like to point some of the achievements. For example, like the speech, they created 13 important new AI technologies. Voice interaction technologies were selected by MIT Tech Review as 2018 top 10 scientific and technology progress. And also, I would like to highlight City Brain, as I just mentioned. So City Brain is very famous in China. For example, like the ambulance, so they actually do a lot of optimization job for this ambulance time. So currently, they can save half of the time of the ambulance before, after it receives signals and deliver the patients to the hospital. Half of the time, it means it can save hundreds, I cannot say hundreds of millions, but it saves quite a lot of, people's lives. Okay, this is the computational layout. It's more related to chips, new computing platforms, and the database key technologies. Yeah, okay. One thing I would like to point out here, because I am also involved here. We built the world's largest community knowledge graphs, because currently, as Daniel he mentioned yesterday, we have more than 700 million buyers on this platform, and over 10 million sellers on this platform, and actually more than 2 billion items, and hundreds of billion of edges among these different heterogeneous nodes. So currently, it's the largest community knowledge graph in the world. Okay, so this is the new tech layout, like the quantum computing, the autonomous cars, blockchain. I think you've heard quite a lot of the blockchain. Okay. Now it comes to my part. So regarding this graph neural network in practice, so I just summarize in one sentence. So I actually heard a lot of debates, challenges regarding the deep learning, right? So here I come. So definitely, regarding this deep learning, it has 2 main drawbacks. The first drawback is explainability. It's a black box, right? Even you get a really good prediction answer, then why? You don't know that. It's just to predict what. And a second reason is that it cannot do inductive reasoning. Deep learning is really good at pattern recognition. So the breakthrough areas currently deep learning got, you can just name it, for example, like speech, vision, image, right? These areas all contain very strong patterns. So that's the reason how, deep learning can work really well. And the graph neural network, people consider as a second generation of the AI technology, because some of the people consider the real first generation of AI technologies is almost equivalent to the deep learning. Now, what's the second generation? Okay, so first, I would also like to point out that graph data is really prevalent in the world. For example, like the social network, the internet graph, like the user item bipartite graph for the recommendation that I just mentioned, the traffic graph, right? The electricity grid, the online behavior targeting. This is for the computational advertisement, the gene analysis. However, why it hasn't been, dominant for quite a long time? The reason I think is that for 2 reasons. The first reason is that for the system, because graph computing is quite different from the parallel computing. You cannot just randomly split the samples and send to the workers and do the centralized computing. You just lose quite a lot of information. The second reason is that before GAN comes out, traditional graphical models, they deal with the homogeneous graph. That means the topology structure is just one. However, as I just mentioned, for this user item bipartite graph, it's a heterogeneous graph. You have various kinds of edges linking between users and items. For example, impression, click, conversion, add to cart, add to purchase, right? And you also have different attributes for the nodes and for the edges. Each of them represent a different topology structure. Then what you have to do is to unify the different topology structure consistently and get a consistent embedding. That's actually quite challenging. So this is quite different reasons. So I just break very briefly. So the first one is graph data is really prevalent. The second one is actually regarding the traditional recommendation. As I just mentioned, the recommendation search, computational advertisement are the core business, the core business of the big data company. They're actually just a special case of the graph computing. And especially graph computing, their objective function are more general. However, it can introduce more risks. For example, it introduced high-level proximity samples. So I will not give more details here. But the last sentence I would like to point out, it was selected from one of the papers that listed here. It's actually had to be updated. Currently, it's not only on archive. I think it's already accepted by top conference or top journal. This is a bunch of really good people from this Google Brain, Google DeepMind. As they mentioned, pure deep learning is mature. Graph embedding or graph neural network that combines both deep learning and graph computing, integrating end-to-end learning with inductive reasoning, which is expected to solve the rational reasoning or the inductive reasoning that the deep learning cannot perform. Okay. So this is several challenges. I will really go through that quickly. So the first is large size, because the current data that we are dealing with is hundreds of millions of nodes and hundreds of billions of edges per day. That's the data you have to deal with. And also the query per second, the QPS, that means how many people's responses you have to feed every second is over 500,000. So that means your modeling needs to be really efficient. Okay, so that's for the system part. The second part is how to elegantly integrate the heterogeneous information. That's what I just mentioned. You have multiple topology structures. How would you like to unify them together? The third is that your model has to be inductive, cannot be transductive. Transductive means that some of the models, statistical or machine learning models, they can only do inference or prediction for samples that have already observed. That means transductive models, quite a lot of actually. Inductive models means that your model has the ability to predict those samples that you haven't seen before. And for Alibaba, there are quite a lot of new users registered every day, new items listed, right? In that sense, your model really has to be inductive. The last but not the least, which I still consider the most challenging part, is that how your GN model can be dynamic, not only for modeling, but also for system as well. Okay. So this is just a GE-oriented recommendation system in practice. So as I just mentioned, this is a user item bipartite graph. It's a heterogeneous graph. And after you do this GNN modeling, you can unify them into this space. And there are some fundamental directions that my team are currently working on. Just one sentence here because there's more details. This paper has been accepted by the top conference of the system called VLDB, Very Large Database. So you can just looking more details here. But one thing we'd like to notice for the extremely large data, large modeling, I do not like to build a very complex modeling, but we would like to go into detail some of the fundamental directions that it can bring you very significant increment regarding the performances. Okay. So this is actually, we call this cognitive. Yes, actually yesterday, Professor Spence, he mentioned one of the trending is the cognitive and learning. I'm really excited about what he said. That's what we're currently doing. We think this is the cognitive intelligence algorithm platform. Why? Because GNN, graph neural network, it can do the inductive reasoning. Guess, what is your next steps? And also, very fundamentally, we brings in the GNN and the NLG, natural language generation, video understanding, video caption, caption generation together, so that we can communicate with our consumers. We can tell them why we recommend these items to you. If you buy this item, what you can do, something like that. Okay. So this is, I'll just go through because my time is just running out. So this is the GNN framework, how you can because after you get this abstraction, it's very easy for the system deployment, because as I just mentioned, the system platform is very critical for the for the graph neural network to contain such a large graph. Okay, so this is the system optimization part. I'll just skip for these details. And we just jump to this GN platform overview. As I just mentioned, there's heterogeneous graph computing. People, if you are dealing with this hardware, you know, CPU, GPU, TPU, NPU, right? And above that, we have this parallel learning inference frameworks and you know, various kinds of these large-scale graphs. And this is actually some of our selected very exciting results we're currently doing. Because we're currently working on this you know, core business of this big data company, and we can achieve around 5% to 90% regarding the precision or the modeling performance lift. And especially, you know, compared to the state of the art of the graphical modeling, if they want to build up the models with 500 million vertices, close to 7 billion edges and rich attributes, they have to spend like 5 hours at least. That's the fastest we are comparing with. However, we only spend like 5 minutes. And last but not least, some other, you know, system you know, development as well. Okay. So this is the last thing. I'm sorry, I'm just running a little bit late, but still I want to consider, you know, this as a really fantastic next step where we're trying to do. So as I just mentioned, I have been doing quite a lot part on this part. It's the machine learning. That's the micro. I consider it as the micro part, because you have to issue prediction accuracy to tell the computer what to do on the milliseconds for an individual user. However, the statisticians, economics, what you are currently doing is on this micro part. You have a lot of excellent strategies, right? But how can these excellent strategies to be deployed to the machine learning to affect each individual person? In my sense, I have done this big data, you know, industry job after my PhD graduation for 9 years. I think there's really a gap, because here, the micro part, you know how to do and why, right? But there is a gap between what to do. So currently, there is a really fantastic, you know, the causal inference framework. I think it originally comes from the statistical analysis, right? It actually tells you the reason why and how to do. And also, it's very robust for the prediction. So there are some other fantastic reasons. So I think, in my sense, that's the connection between the strategy and the machine learning part. So I would also like, in the panel discussion, I would also have to a further discussion, because my time is running out, regarding this part. What are you thinking? What's your suggestion for this part? Because how to connect this high-level micro strategy with the most granular level machine learning people are doing is a really challenging job now. Okay. Oh, this is the last page. It's a bit of words. This is some selected publications of myself. And actually, you can just Google my name, you know, Hongxia Yang, on the website. There's more papers regarding the field of the graph neural network. Okay, thanks a lot.